So guys, in this video we will discuss about that how to fit a parabola as a best fit curve. So for fitting a parabola as a best fit curve, we take that y is equal to a plus bx plus c x square, which is a general equation of parabola for the set of endpoints. So now as we know from the principle of least square method, we take every estimate of the residual of y as u1 is equal to small y1 minus capital Y1, that is y1 minus a plus bx1 plus c x1 square. Similarly, e2 is equal to y2 minus capital Y2 is equal to y2 minus a plus bx2 plus c whole square. And en as well as go on, en is equal to small yn minus capital Yn is equal to yn minus a plus bxn plus cxn whole square. So now from the principle of least square method, we take all sum of all the errors and then sum is equal to u1 square plus u2 square plus w plus n square. And now we can write it in the compact form, that is summation over I is equal to 1 to n yi minus a plus bxi plus cxi whole square. And we can find that I is equal to 1 to n yi minus a minus bxi minus cxi whole square total whole square. So now for finding that this square is the minimum, so for finding the maximum and minimum for a bivariate data, we have to find here del E del A is equal to del E del B is equal to del E del C is equal to 0. So now, and so from del E del A is equal to 0, del E del B is equal to 0 and del E del C is equal to 0 gives us the normal equations, and these normal equations are help us to find the value of a, b and c, and we can fit the parabola as a best fit curve. So now we just find we are trying to find the normal equations, that is now del E del A is equal to 0 implies that if we derive it with respect to a, what we get? That is 2 into yi minus a minus bxi minus cxi whole square into minus 1. This is simple properties of partial derivative. So if we simplify, we get summation yi minus a minus bxi minus cxi whole square is equal to 0. And if we simplify, we write summation yi is equal I is equal to 1 to n and summation I is equal to 1 a plus bxi plus cxi whole cxi square. And summation yi is equal to, you can write na plus b into I is equal to 1 xi plus c into xi square, where every I is varies from 1 to n. Now del E del B is equal to 0 implies that is now we have to derive it with respect to b. So we get 2 into yi minus a minus bxi minus cxi square into minus xi. So if we simplify, we get xi into yi minus a minus bxi minus cxi square equal to 0. And now if we simplify, we get that I is equal to 1 to n xi yi is equal to a into xi plus b into xi square plus c into xi cube, and where every I varies from 1 to n. So now similarly we have to now find the del E del C, that is we have to derive it with respect to c. So now let us see that del E del C is equal to 0 gives us 2 into yi minus a minus bxi minus cxi square is equal to minus xi square. So and if we simplify, we get xi square yi minus a xi square minus bxi cube minus cxi4 is equal to 0. And if we simplify, we get xi square yi is equal to a into xi square plus b into xi cube plus c into xi to the power 4, and where each I varies from 1 to n. So now the normal equations are these, that is summation y is equal to na plus b into summation xi plus c into xi square, summation xi yi is equal to a into xi plus b into xi square plus c into xi cube, summation xi square yi is equal to a into xi square plus b into xi cube plus c into xi to the power 4. These are known as the normal equations, and to solve these three equations simultaneously, we get the value of a, b and c, and then we can find the best fit parabola. So now let us see one problem about this, that is that fit a second degree parabola in the following data. So these are the following data, that is xy, x is 0, 1, 2, 3, 4 and corresponding y is 1, 4, 10, 7, 10 and 30. So the equations of parabola is y is equal to a plus b plus 6 square, and we know that the normal equations are of the form summation yi is equal to na plus b into xi plus c into xi square. Summation xi yi is equal to a into xi plus b into xi square plus c into xi cube. Summation xi square yi is equal to a into xi square plus b into xi cube plus c into xi to the power 4, where each I had is from 1 to 8. So now how can we find the second degree parabola as a best fit curve using this data? So see here we have to obtain summation xi square, summation xi yi, summation xi cube, summation xi to the power 4 and summation xi square yi. So now for solving this, we construct a table here first. That is, the tables are x contain the term x, y, x square, x cube, x to the power 4, x, y and x square. So we put here the corresponding value x and y given here, and now corresponding x square will be 0, 1 square 1, 2 square 4, 3 square 9, 4 square 16, x cube is 0, x cube that is 1 cube, 2 cube, 8, 3 cube 27, 4 cube 64, x to the power 4 0, 1, 16, 81, 250. So this is very simple. Now xy, that is a product of x and y, so this is 0. Next 1 into 4 is 4, 2 into 10 is 20, 3 into 17 is 51 and 4 into 30 is 120. And next x square y, that is 1 into 0, 4 into 1, 10 into 4, 7 into 3, 16. So we get 0, 4, 40, 150 and 480. So now we have to find all the sum of all this term, that is summation x is equal to 0 plus 1 plus 2 plus 3 plus 10, summation y is we get after using calculator is 62, summation x square is 30, summation x cube is 100, summation x to the power 4 is 354, xy, summation xy is 195 and summation x square y is 677. See here n is equal to 5, that is the total number of pair is 5, 1, 2, 3, 4, 5. So now put all this value in the given normal equation. So we get 5a plus 10b plus 30c is equal to 62, 10a plus 30b plus 100c is equal to 195 and 30a plus 100b plus 35c is equal to 677. So now we consider it as the linear system of equation. Ax is equal to b, where a is the matrix, x is a and b is 62, 195, 67. And since we check that data is not equal to 0, so we can apply here the Cramer's rule. So you can solve it also these three simultaneous equation by eliminating the terms a, b and c, or you can use the Cramer's rule. So if we put now the Cramer's rule, so we get the value of a is 1.2, where mod a denoted by the date a, b is equal to 1.1 and c is equal to mod a, that is 1.5. So now we can say that the equation of parabola of the best fit is y is equal to 1.2 plus 1.1x plus 1.5 x square. This is the required equation for the parabola as a best fit curve for the given set of values. So I hope you understand that how can we fit a data, how can we fit a parabola as a best fit curve for the given data. So thank you.